Yeah, so AGI 2022, a year in review. Let's go. This talk will have three parts. First, I'll be talking a bit about technologies, particularly the new developments in image and language generation and processing models that have come out in 2022, and how what kind of technological changes have happened in the past year that may or may not have been big steps in terms of AI technologies. Then I'll be talking about narratives. This is the part I'm personally most excited about because a lot of the way that people talk about AI has changed in 2022, and not just the way people talk, of course, also the way people think and conceptualize AI. And then the third part is going to be pathways. So how have people's timelines in terms of AI development have changed in 2022, and what does this mean for maybe this year or the coming years or decades? So first, let's talk a bit about technology. So as you can imagine, the picture on the right has been generated by, in this case, Stable Diffusion. Diffusion models have been, particularly in the first 2 quarters of the last year, maybe the dominating topic in terms of AI technologies. We've had a flood of them coming out within a few weeks of each other. So DALL-E 2 by OpenAI is, of course, one of the first ones that came out of this generation of image generating models or text-to-image models. We have Midjourney, which was probably the first that the general public could interact with via a very, very interesting Discord interface. That was a ton of fun to play around with. And of course, Stable Diffusion was then the first major text-to-image model that was open source, publicly available. You can download it from GitHub and run it on your own machine. And then you had the later ones, which were sort of Imogen, Disco Diffusion, and these kinds of derivative models that sort of improved on several aspects of the original generation of diffusion models. And so the question is, of course, we've had image models before. What's the difference? Why are these so talked about, and why did they cause such a stir? I won't show a bunch of generated images. I'm sure you've seen many of them. This one here has, of course, been generated, and it is photorealistic. So what caused this change? And the main change here, and we will see this pattern again and again, has mostly been scale. So both the scale of the models themselves in terms of parameters, but also the size of the data sets they've been trained on have been increased. In terms of technologies, actually not all that much has changed. So the fundamental paradigm of diffusion as an algorithmic component that underlies all of these models is somewhat new, but it is also not all that crazy. Basically, the idea is that you add noise to an image and you train the model to just predict the noise. And you do this in a iterative way, and if you're smart about it, you can actually then, by removing it, predicting noise and removing it, predicting noise and removing it, actually generate images. It's actually a very simple idea mathematically, and yet somehow by scaling this up with huge amounts of parameters and huge amounts of data, you manage to actually get extremely convincing images. So technology-wise, very simple principle, but applying scale to it essentially causes this to very extremely easy computational paradigm to generate vastly complex outputs that are quite astonishing. So the second area where we saw sort of a similar pattern play out was the era of large language models, and this was more the second half of 2022. Of course, Lambda is one of the earlier models of this. It's been announced. We haven't really known much detail about Google Lambda, except that Google said, oh, this is crazy, like we can do a lot of things with it. I also believe, I hope I'm right about this, that Lambda was the model that this Google researcher who said that, okay, this thing may be conscious. That whole controversy was about. He was later fired from Google, and there was this whole personal thing. I don't personally care much about the personal thing. I just found it interesting that nobody really knew much about Lambda, but there was this controversy, if you remember. And there are similar models, Chinchilla, Minerva, Pathways model, that are all sort of these large language models, but of course ChatGPT has been the one who has blown it out of the water in, I think, November 2022 when it came out. And it immediately dominated the entire narrative. Basically flooded out all of the previous large language models that people have been talking about, and everybody now has only been talking about ChatGPT. Probably for good reason, because, and this is a thing that I found absolutely shocking, and that this particular, like, one blog post that I read sort of changed the way I thought about my personal timelines, which is this little image where you see, okay, actually, in ChatGPT, you can tell it, hey, ChatGPT, act like a Linux terminal. Okay, fair. And then afterwards, you can give it commands like to a Linux terminal and to emulate the output. Fine. You can say, hey, ChatGPT, don't just act like a Linux terminal, but essentially act like a virtual machine of a Linux computer. And you can do things like on any virtual machine. Okay, fair enough. It simulates a virtual machine. What's the big deal? And then inside this virtual machine, you can tell, hey, ChatGPT, go to ChatGPT's website and find the web interface for ChatGPT. And it simulates its own web interface. Okay, fine, fair enough. Maybe it's been part of the dataset, you don't know. But then you can go, hey, ChatGPT, in the simulated version of your own web interface, write the prompt that simulates a virtual machine. So, and this is where you can see the output down here. You can see that it prints out the user directory in a Linux shell, which has been simulated inside a simulation generated by ChatGPT. So now we have like 2 levels of virtualization that has been simulated in a large language model, which is insane. The amount of, to me personally, the amount of context required to have been sort of processed by this model is absurd to be able to virtualize, to simulate 2 levels of virtualization. So anyway, as a computer scientist, I found this example particularly striking. Other people found there's been a lot of other sort of controversies about ChatGPT, for example. Of course, you can now generate abstracts for your paper by ChatGPT. You just feed it. This has been, I mean, people now say, oh yeah, of course you can do this, right? But half a year ago, if you told them, okay, you can generate a perfect abstract for a paper simply by feeding it the paper, people would say, I don't think so. It must make mistakes. No, it doesn't really make mistakes. It passes the Turing test for scientists easily. This is not really, Turing test is not really a measure anymore. Also, yeah, probably many people have heard about this, so it passes, like it passes a somewhat standard IQ test with an IQ score of, I think, 82, overall, 83, which is, you know, many people have IQs of 83. So we're not very far away from at least being able to pass IQ tests pretty damn well. So, you know, this happened. And then, of course, I'm a roboticist, so you can say, okay, now, I don't really care about ChatGPT because it's locked in a machine and, you know, it can only talk to people and maybe people are smart enough to deal with this and whatever. And I always find it interesting when machines actually interact with the real world. So there have been early applications, and I had the pleasure to review this paper actually for a conference, Code as Policies for Google. And I was shocked when I read it because they don't use ChatGPT, but they managed to, and it's actually already available, you know, so as a preprint, so you can have a look at it. But they use a large language model to generate robot code directly. And this code is pretty executable without modification. So you can essentially tell your large language model, I would like to, I don't know, move this fruit from one side of the table to another. And the robot will then move the banana from one side of the table to another. Because the whole code generation and language understanding pipeline has been implemented with large language models. So we can say that now we can relatively easily build systems that actually act in the real world. And this is another example a bit later, that do essentially the same thing, generate robot task plans using large language models. So also in areas which are a bit away from the application, from like, okay, only text generation, abstract generation, summary generating, etc., machine translation, you can already get applications of large language models that actually influence the real world. So again, you can ask the same thing, why did this big change happen? And essentially this is a very simple principle, transform is a simple principle, right? But the idea is basically you take context, so it's essentially self-supervised, so you give it a bunch of text and it predicts the next token based on the context of the current word. And this has been around for, I think, pretty much 3 years now, with the Attention is All You Need paper, where it's been originally proposed. same principle, not really much modified, but way more parameters, so way more layers. They now use, GPT-3 uses 96 layers of its decoder, transformer layers, and way more parameters, 175 billion parameters, and just way more trained data. So just by scaling up model size and scaling up trained data, we have achieved the kind of level of performance that ChatGPT achieves, except, and what is very interesting, is that when you go from GPT-3, which is sort of the base technology that uses transformers in the way that we've always used transformers, self-supervised training, if you go to ChatGPT, it's actually kind of funny, because now they add human supervision back in the loop, so they did actually quite a lot of human labeling and supervised learning to train ChatGPT to become so powerful as it is. Which is an interesting shift, because we used to talk about, okay, human supervision is not scalable. People said, okay, we can't deploy via supervised learning extremely powerful AI model because humans are too slow at labeling all this data, or it's too, it takes too many resources to do all this labeling. And self-supervision is sort of the way to go, and you want to learn representations autonomously, etc., etc. Turns out, actually, now, if you do relatively little human supervision on a model, GPT-3, which has been trained largely self-supervised, so it's kind of a hybrid training paradigm. The machine does a lot by itself, and then the human does very little. But just by giving this little high-quality supervised data, you go in capabilities from GPT-3, which made quite a lot of mistakes, to ChatGPT, which is extremely good at fooling people, passing the Turing test, etc., makes very little mistakes in terms of its language model. And the only mistakes it really still makes are semantic mistakes when it confuses concepts. So again, this is a sort of interesting technological aspect, which I did not really anticipate, the fact that human supervision has kind of returned into the game as sort of the salt in the soup that makes an otherwise not very powerful model suddenly extremely powerful. So overall, right, it's been a pretty good year for the scaling hypothesis. Scaling hypothesis, again, here you see two graphs. There are going to be a lot of graphs in this presentation. I hope they're not too intimidating. I will always talk about them. Here the idea is, okay, we've had the amount of compute used for training increase over time as you go from 2011 to 2022. And we've, of course, have had the amount of parameters in the models increase pretty much by the same scale. So you see compute increases and parameters increase. And there's been this sort of Moore's, like we've been speculating that there's maybe a Moore's law for AI, which is essentially a codification of the scaling hypothesis. So if we increase the amount of compute, the amount of parameters, and of course the amount of training data, then we can keep getting models that get better and better. And there's no real limit to that, aside from maybe the amount of compute that we can have on our planet or in the universe for physical reasons. Right? An interesting perspective to take on this, and I will come back to exactly this slide in the pathways part of this talk, is that now Google this year already trained a model with 1.6 trillion parameters. Konstantin also talked about this on the first day of this retreat, that essentially, if you remember the bioanchors post, maybe sort of a way that, okay, we can extrapolate how future AI progress looks like by looking at how big the model sizes are and how big biological analogs are. So a mouse, for example, has 71 million neurons, an octopus has 500 million neurons, so we are roughly around that size sort of already if you convert model parameters to neurons. The human brain has about 100 trillion synapses. If you say, okay, a synapse is kind of like a parameter, it has a synaptic weight, maybe it's sort of analogous. GPT-4, which is supposed to come out this year, has 100 trillion parameters, so that can be argued to be the size of a human brain by some measure. So of course it's not a perfect analog, but still. So if we look at the bioanchors method, already just by scaling up models, we are on this timeline already a couple of years ahead. So they say 2023 first mouse brain-sized model. Well, we kind of already have the first mouse brain-sized model in 2022, so we're already like 1 year ahead. And projection for first human brain-sized model on easiest task, mind you, 2036. Right? So by some measure, you can say GPT-4 might already be human brain size, depending on how you measure it. And it doesn't solve easy tasks, it solves very difficult tasks. At least I argue. So what does this mean? Are we 13 years ahead of the timeline that bioanchors predicted? I don't know. We will see in the pathways part of this talk, though I don't really have answers. It will just raise more questions. Then there's been this concept of neural scaling laws, which many of you probably have heard in the discourse on AI. Conventional wisdom is that the empirical performance of machine learning models has a power law relationship with compute dataset size and parameters. So if you scale up your model, your performance also increases, but it's a law of marginal returns. So eventually it will level off and it will become exponentially more difficult to increase your model performance. You see this in these plots. These are like log-log plots. So if you unlog that, you will get a power law. And you this is 2020. Okay, we thought fair. We will keep getting better models, but it will be much more difficult to get even better models later on, and you will have to increase model size by a lot. Well, it turns out that there was a paper this year that found a sort of interesting dynamic that if you do this on real-world datasets, what actually happens is you get broken power laws, in the sense that there are sort of breaks where if you go above a certain size in your dataset, then suddenly model performance becomes significantly better. So here you see that you take the loss, for example, and the loss decreases, then maybe it increases a little bit, but then it hits this break where suddenly, so if you keep scaling, you get a significantly steeper slope where your loss decreases. So on some, and they've shown this on sort of artificial datasets, but the hypothesis is that what they've shown on artificial datasets may also hold and partially explain the very good performance of models on current real-world datasets. Yes?
How is this related to grokking?
Yeah, very, very good question. Next slide, we have grokking. So grokking says that on some also datasets, which are, again, artificial datasets that they've created, the validation accuracy sometimes suddenly increases to near perfect generalization. So validation data accuracy is the accuracy of your model, the performance of your model on a data set it has not seen during training. So this is a measure of generalization, sort of a weak generalization in a way. And you need this for a model, so if your model overfits, then it performs very well in the training data, but not good at all in the validation data. This is a bad model. You see this here. So this is classic overfitting, right? Validation is the green line. So you don't get better on your test data set or on your validation data. You get near perfect performance, near 100% score on your training data. By this point, your model is useless because it will not be tested on your training data, so you say, okay, this is a bad model. And then nothing happens for a long time, except that if you keep on training, and so this is sort of a, not really scaling in terms of making the model bigger, but just training longer. Eventually, it figures something out, and then it has near perfect performance on the validation data. So this phenomenon has been observed. It's called grokking. And it's like going from sort of a small brain type model that doesn't know much to like the galactic brain model, which has suddenly figured out everything about the data and has near perfect performance. So again, these kinds of dynamics sort of show that, okay, model performance may scale even more than we would expect simply by the scaling hypothesis. Because phenomena like this, which we don't fundamentally understand yet, may happen. Then there's been another narrative, which is also kind of fun, which is the architecture hypothesis. This is something that not very many people outside of the AI field kind of know about. But Jan LeCun, who is a very famous AI researcher at now Meta, made the controversial statement that designing architectures and training paradigms for the world model, so in the model of an AI that it has of the world around it, constitute the main obstacles toward real progress in AI. So it says that not scale, but architectures and training paradigms, so a sort of algorithmic or architectural choice that we make. And there's been a lot of controversy around this. So this is a Twitter sort of thread that has happened where Ilya Sutskever, who's also a very famous AI researcher, said that, okay, it may be that today's large neural networks are slightly conscious, and Jan LeCun just said nope. And he says that you would need a particular kind of macro architecture that allows for consciousness. So he says consciousness will essentially not just emerge if you keep scaling up your models, but you need a particular architecture. This is, I just wanted to throw this in there. I don't know how true this is or not, but this is the model that he then proposes. It's called JEPA. I don't want to go into the technical details. Fascinating paper, position paper, and very controversial. So if you like the controversy around that, read the paper. It's written very understandably. And basically, what you have is a neural cognitive architecture that he proposes, where you have different models with different neural implementations, algorithms used to sort of model different aspects of cognition, because also in the human brain we have different kind of neural circuits that do different things. And to apply that principle to large neural networks, he says will actually get us closer to an AGI in a way than we would just by scaling up one big model. That was interesting. So this was the first part. I suggest we're a bit tight on time, so I'd like to hopefully do some discussion at the end if that's okay with you. Because I'd really like to talk about this narrative question. And the first thing that's kind of been changing is before we thought, okay, in terms of neural network capability, generalization is the bottleneck. So we always thought, okay, it's very easy to train narrow AIs to do one specific task. We've had a lot of those, and it will be extremely difficult to train AIs that can perform well on a large variety of tasks. Well, it turns out that in 2022, this wonderful paper called A Generalist Agent by DeepMind came out, and they presented the model Gato, which I had the same assumption, and now I don't assume this anymore. I think now generalization is not really the bottleneck anymore in terms of model capability. Why? Because Gato was essentially trained on tokenized sequence data from a large amount of domains: language, robotics, vision, reasoning, symbolic reasoning. And this same model then produces also outputs in all of these domains. And you can use it for cross-domain transfer, which is awesome. You can give it language instructions and it makes a robot do things. This is one of these models that directly do this. So it does cross-domain generalization, which people thought was very difficult to do. It is by far not a perfect model, so in this paper they actually acknowledge a lot of weaknesses that this has. But it is one of the first models that sort of scalably demonstrates the principle that we can have a foundation model that learns sufficiently generalizable representations that are helpful across a wide variety of domains. So this narrative has changed, right? Generalization may not be the bottleneck anymore when talking about the performance of models. What's been a big update for me this year is the 2022 was the first year when I really started thinking about AI alignment as a concept. And the concept of AI alignment has not just been on my mind, but also, of course, on the mind of many, many more people. Here you see the percentage of posts on less wrong by tag. So less wrong posts for AI have sort of, here's 2022, and you start to see this is when it really started taking over less wrong in a way, as a forum. So people have been talking much more about AI, okay, AI alignment, maybe not, but it also turns out that the number of AI safety researchers in the world has been increasing actually by a lot. So also here again in 2022 we see this sort of exponential increase that has been happening, has been continued. And of course, probably we will need many more than there are today. The same thing goes for AI organizations. In 2022 we've had kind of an explosion of new organizations founded that are actually quite prominent, so Conjecture, many people know this, or Anthropic was actually founded in 2021, but still sort of recently we've had a lot more AI alignment or AI safety focused organizations being founded. So people have the narrative that AI alignment is a thing that we should care about, has, I think, been solidified in 2022 to a large extent. AI alignment narrative has also entered the mainstream. So we see that large organizations like OpenAI now makes it one of their core missions to align their AI, which is somewhat new. Not seen this before. Also, again, Google says the same thing. Now they have responsible AI practices, which is also somewhat new. DeepMind also does. Now, there's also a lot of other companies that don't write it explicitly on their websites, but still participate in a partnership on AI, they call it, which also has alignment goals. You also see this in big discussions on AI safety, machine consciousness, etc. enter the mainstream in terms of popular journalism. So you see this in news, you see this in the New York Times about chatbots, you see this in The Guardian. The question is, has it really entered the mainstream? Because you also see, parallelly, a lot of very annoying posts on forums like LinkedIn, etc., where marketing agency says, oh yeah, this ChatGPT is like the most powerful tool to reach sort of a large audience with your targeted ads. Great. Maybe this is not the way the mainstream should be thinking about these models. That's just what I'm saying. Right, I mean, I see this is like literally a screenshot from my LinkedIn, where my blood pressure increased immediately when I saw this. Because it's like, oh, hey, yeah, writing great software code according to ChatGPT. And so this is like, hey, we should actually, large language models write better code than humans. And we should just adjust our coding best practices to say, okay, use ChatGPT whenever you can, and it generates better code than you can. No, I don't think so. And I think this kind of thinking, at least unreflectively, is a bit dangerous in the mainstream. So this is another kind of narrative that, yeah, has been happening. There's also social political impact of AI that has become much more of a focus in 2022. So people have been talking a lot about ways to generate science output, like models actually participating in science. I haven't heard this scalably happen before 2022. This is something I think that's relatively new last year. And the fact that this is also problematic has also kind of been discussed. As in this case, for example, with Galactica, which was actually talked about a lot. My boss, the day after it was released, immediately came to me and said, oh, did you see this? And then 2 days later it was shut down. We see this also with, of course, the narratives around fake news, propaganda, etc., which has been talking about in the context of ChatGPT. We also have had studies, which I find interesting, into the political leanings of AIs, which is also, again, a thing that these things are basically just a collection of links, so if you have the slides later, you can just look it up, because it's actually fascinating to read about these things. And it turns out that ChatGPT seems to have a slight left-liberal bias. But of course, if you start studying this about ChatGPT and you train another model on different data, you may just get a very different bias. There's also been a lot of varying discourse on AI alignment on a technical level. So before 2022, a lot of people said, okay, we need to build AI systems which cannot be internally misaligned, right? This is a survey by colleagues of mine at the University of Stuttgart that we worked together, and they did a survey on explainable machine learning 2020, right? This was like, okay, very promising field, we want explainable AI deployed in the real world. Probably pretty robust as a heuristic. This is also in Paul Cristiano's talk. This shows up a lot back then. It was at some EAG event, he held it a few years ago, in 2020 actually also. This whole branch of his sort of alignment, tree of alignment methods, basically everything that comes down from there is essentially explainable AI, like how to make algorithms alignable. It turns out that this has kind of been abandoned to an extent. Instead, they started doing things like, let's not try to build explainable AI models anymore, but let's learn how to understand fundamentally unexplainable models to an extent. So let's learn how to reverse engineer machine learning models. So we've gone from engineering to reverse engineering. This is also called mechanistic interpretability. If you Google this, Chris Oler is one of the people who does a lot of this in terms of visualization of internal representations, which is fascinating. The problem is that there's also been a narrative building, since we're also in the narrative category of the talk, that this may or may not be tractable. So it could be that our models have become so big that the amount of compute that we need to understand the models is like approaches the amount of compute we need to train them, or even exceeds it. And this is of course problematic, because this means that we may never be able to understand these models as much as we'd like. Again, the jury's out on that. And there's been a third narrative, which I find somewhat dangerous, which has emerged, this is just to slow down progress. And there's the picture here of the Luddites, of course, which are smashing equipment. Which is basically that we can't align models, we shouldn't even bother trying, we shouldn't even bother understanding, or well, maybe you should bother understanding, we just need more time. And in order to get that time, you should just slow down progress on AI, capabilities research at least, until we have figured out a way to make them safe. Reasonable proposal, probably, but again, this is just a narrative that's been happening, and the discussion on this would actually be extremely interesting. I think whether this is actually desirable from a social perspective or not. There's been this whole controversy which kind of kick-started this narrative when Eliza Yudkowsky announced this whole death with dignity thing on April 1st. Phenomenal day to announce such a thing, because it just amplifies the meme value so much, because you just don't know, right, how it's meant. But it turns out that other people have also sort of substantiated that narrative and have been posting things that essentially say a similar thing. So the whole thing in itself doesn't really seem to have been a complete shitpost, but rather actually a narrative that people take seriously. And that, yeah, people who also are interested in AI safety and capabilities should take seriously, and should at least look at the arguments that are presented, whether or not they agree with it. So now let's look at some pathways. This is the last part. Maybe we'll have 5 minutes for discussion afterwards, or during lunch. I would love to have discussions during lunch. So I talked about bioanchors earlier, and how basically our timelines are already ahead of bioanchors when it comes to the scale of current models. So the amount of the model size and compute that is used to train has increased faster than the bioanchors method predicted a couple years ago. So again, there already you see that, okay, maybe people's timelines should shift, at least if they use bioanchors as a heuristic. Now, this is the researcher behind bioanchors. And they said that in 2020, when bioanchors came out, that, okay, in 2036, there's a 15% probability of transformative AI by then. What is transformative AI? Again, up to definition. But this was like 16 years from posting this, which at the time was a pretty, pretty fast timeline. And a median sort of like, this is 15% probability, median, like by 2050, we'd have transformative AI. 2022, this researcher has decreased their projection by 6 years for the 15% chance, and even a 35% chance by 2036 of transformative AI. So timelines have just shifted forward radically over the span of 2 years. So this is an interesting thing, and they know a lot about AI, so this is the person that maybe somewhat knows what they're talking about, probably. So people's timelines may have shifted. Now, this is one person. If you ask many people, and this expert survey, I've already seen it a couple times this weekend, and it's fascinating. I encourage everyone to read it, because it gives somewhat a different perspective. I thought, okay, now I got a bit panicked, right? People would start shifting their timelines. I talk to people get scared. AI doom is happening. And I read this expert survey, and they expect the same thing. I was actually somewhat surprised that the median expert predicts sort of human-level machine intelligence in 37 years, which is like 50% chance of human-level machine intelligence, which I would consider a rather conservative timeline by the standards of people that I talk to otherwise. Now, the interesting thing is that 6 years ago, 2016, this was 45 years. So we did have somewhat collapsing timelines, but not on the scale that you see from someone's like, say, Eliza Yudkowsky. So the median expert on AI is still a bit more conservative with their timelines. What did also increase is, again, this is sort of a quantitative substantiation of the AI safety narrative, that people should prioritize AI safety. Yes, that has increased, and the median respondent now also thinks that maybe there will be an intelligence explosion, but not that much, right? So about 50% of experts still, basically, that hasn't really much shifted, thinks that there may be an intelligence explosion or not. Again, whether or not this will happen, I don't want to make a statement about this. I really don't know. Yeah, and if you ask prediction markets, now this is also interesting. This is a point where how you see how narratives really sort of start taking off by themselves. Because this dashed line is the month, maybe even the exact day, on which Eliza Yudkowsky posted this, so April 1st, 2022, a couple months after these large DALL-E 2 image generation models came out. Where he posted this basically first AI Doom post. And then you see suddenly like timelines start shifting a lot and kind of, oh, this was May, yeah, so they started decreasing a bit before in April and reached their lowest point in May and haven't really increased since. So there's been sort of a collective shift in people's timelines as a response to and sort of interaction with the narrative of, hey, maybe we cannot align AI. And the expected overall AGI timelines by people on Metaculus, which has, of course, a huge self-selection bias, have shortened by 10 years, just in that spring of 2022. Now, the last thing I want to talk about really is the short versus long-termist view. And there's an interesting discussion that's been happening last year by Eliza Yudkowsky versus Paul Christiano, which is also interesting just to read. These two really, I mean, there hasn't really been a convergence in 2022 whether sort of there's a short or a fast takeoff. Right? We don't really know much about that, but the sort of existential risk perspective with what we are the future that came out last year sort of emphasized maybe the dangers of a fast takeoff. So, which will happen in a longer time, but then will be could be catastrophic. Whereas my personal intuition and the intuition of Paul Christiano is that there will be transformative aspects of AI happening much before that, and the sort of takeoff in capabilities will be sufficiently large earlier to cause significant social change, and we should maybe think about this in a short-termist view also, rather than exclusively focusing on existential AI risk. So yeah, we have about 7 minutes for discussion left before lunch, and we can always carry this discussion into lunch. That'd probably be fun. So my questions now, maybe if you have some intuitions, are this is just to inspire discussion. You can really talk about anything. Is like, to what extent have your timelines changed? Or to what extent has your perception of AI as a technology changed? Or as a research discipline, if you're an AI researcher and you feel like, hey, how has the field maybe changed just in this crazy past year? And of course, the question that is now becoming sort of the dangerous question, how do you think progress should be slowed down? It's a very difficult question. And of course, have I missed anything? Yeah.